welcome everyone. Thanks a lot for joining us today for this Lunch and Learn. So yeah, as Dave mentioned, I'm Nick. I head up data science in one of our functions here at M&S. So my team are focused on growth and personalization. And we're joined also by Sam and Duong, who are two data scientists in a couple of our teams here. So we're going to be talking today about how we've been scaling machine learning at M&S over the last 18 months or so, and how and why we've been building up capabilities in MLOps to support us in this work. So I'm going to start by setting a bit of context about our team, what we're working on, and how we work at M&S. And then I'm going to go a bit deeper to talk about some of the challenges we've faced operationalizing and scaling machine learning. I'll describe how some of these challenges have led us to create an MLOps culture over the last year or so. I'll talk about why that was needed and what we've been aiming to achieve in terms of that work, as well as how we're measuring our progress over time. And I'm then going to be handing over to Sam and Duong to bring this story to life a little bit more. They're going to be talking about some examples and case studies from our teams and how we've implemented MLOps in some real projects. And then finally, I'll be wrapping it up. I'll be summarizing some of the progress we've made so far and the outcomes we've driven across all our teams here at M&S. So, to get started, so at M&S, we are all part of what's known as the central data science team, which is part of a relatively new department at M&S called Digital and Data, or D&D. So D&D has a remit spanning across all areas of the business at M&S. And in our central data science team, we tend to be split across two different areas. So around half of us are based in customer-facing teams, and the primary goal of those teams is really to personalize and tailor different marketing initiatives so we can drive relevance in the way we communicate with our customers, and also to personalize and tailor online experiences too. So some of the ways we do that are through deploying things like recommender systems online to provide more relevant product recommendations to customers. And then we also have a team focused on driving loyalty with our customers. Many of you will have heard of our loyalty scheme Sparks, which was relaunched 2-3 years ago now. And yeah, some of our teams are focused on personalizing the offers we send to our customers, again, to drive loyalty. And then other than those customer-facing teams, we have a large team that we call enterprise data science. So they're largely, they're considered non-customer facing, and they're largely focused on optimizing different business operations, such as working on things like price optimization and markdown optimization, working on stock allocation problems. And we've also more recently started up a team we call retail data science, who are focused on like in-store applications of data science. So lots of really interesting opportunities in that space being worked on and still to come as well. So all our data scientists are heavily involved in building and operationalizing machine learning systems. And I'm going to be talking now a bit more about some of our experiences building and deploying machine learning systems, and also some of the challenges we faced over the last 18 months or so, both technical and non-technical. So yeah, I joined M&S almost 18 months ago, and the team I joined were in the midst of productionizing what was the first model in our central data science team. So this model was for a marketing use case. It was aiming to drive relevancy in the communications we send customers, improve engagement, and reduce lapse, the people who would unsubscribe from marketing communications. And certainly I very quickly came to realize during the process of productionizing this model that there was a lot of pain and a lot of difficulty bringing that model to life end to end, largely due to our ways of working and our team structures. So, I've illustrated on this slide here, kind of roughly like how teams were organized at M&S. As you can see, in this one use case, there were many different kind of people and teams involved and that were needed to deploy that solution end to end. We, as a data science team, we were communicating with many other teams who were involved in some way, either in defining that use case or helping automate and productionize it. There were many kind of specialist disconnected teams involved. Many of these teams, use different environments and different methods of communication, whether code-based communication or otherwise, through meetings and slide decks, for example. Many of our teams had limited permissions. Data science at that time, we were using a Databricks development environment. There was a different Databricks environment that we didn't have permission to use for testing, and then a third environment that was used for production. Some of our data engineering teams would have privileges to make changes in one of those environments, but ultimately would have to hand off to an ops team. Inevitably, teams were having to hand off work and code to other teams, gradually losing context across those different teams. There were many dependencies on different people and teams in that process. Work was having to be scheduled upfront, sometimes several months upfront, to get the support needed to deploy this end to end. And likewise, some of that support was dependent on these teams' priorities at that given point in time. As you can imagine, there were some major implications about working in this way. Inevitably, when it was so difficult to align work and schedule work in across teams, there was a tendency that work would be done in big batches. And then just handed off to other teams, in one go after a big phase of work. So that resulted in slow release cycles, having to deploy big changes at once, and ultimately that increased risk of bugs in those changes, because it becomes very difficult to test all those changes thoroughly in one go. And it also leads to delays when there are issues. Things have to be handed all the way up the chain or all the way down the chain in order to rectify those issues. Ultimately, that leads to slow feedback and learning about whether things are working as you expect, and any issues you might come up against. And it delays the creation of value as well. You can only create value late and in the process, and at irregular time points, rather than ideally early and often. And then perhaps most importantly, this whole process, as far as I see it, was leading to a lot of frustration and disempowerment in the teams, when no individual people or even individual teams could take ownership of the full solution. So off the back of that experience of taking the first model to production, it was pretty clear that we knew we had to find a much better way of working in order to really scale machine learning across the business and drive wider impact and wider, better outcomes in M&S. That process was inefficient, it was error prone, and it was disempowering for people. So off the back of that, we got together across, I think the leads in data science and some of our data engineering leads as well, and thought about how we can improve and what we like to achieve in an ideal world, and that led us to set up an MLOps initiative, and the three primary goals, which I'm going to expand about now, are really that we wanted to empower our teams to take greater ownership of the solutions that they're building, and avoid having to just hand off to other teams who had limited context of a problem or the solution or the code base, in order to get those solutions deployed end to end. The existing process was slow, and really to get buy-in for data science, we knew we had to accelerate that process. We couldn't go on taking months and months of development before being able to test and learn on real customers and gain real feedback, before working out whether what we'd built was working effectively, driving value for customers in the business, or whether there were issues or some of our assumptions were not correct. And then we also knew, we needed to build higher quality solutions that would be, wouldn't break every other day, which, admittedly some of our early jobs were doing. We needed to build like engineering best practices into our workflows. We needed to build observable pipelines, reproducible pipelines. And we needed to think about how these jobs would be maintained, in a year down the line, 2 years down the line, 5 years down the line, rather than just building for today. So I'll talk a little bit more about what we mean by these goals. So our first goal, aiming to empower data science teams. So for me, what we're aiming to achieve here, I think there's a famous quote from Werner Vogels, who's Amazon's CTO. So I think he originally said this way back in 2006, but he said to his devs, if you build it, you should run it. And his point here is that by empowering developers to actually give them responsibilities and accountancy for running the solutions they're building, it leads to better products and faster workflows than having to hand off to other people. And for me, that spirit of you build it, you run it, encapsulates what MLOps aims to achieve, and what we've been fighting for our teams here at M&S. So I think this is nicely encapsulated by this image here from the MLOps org. You design it, you train it, you run it. So in terms of empowering our teams, some of the things we've done to empower people, proactively looking to reduce handoff to other teams, negotiating permissions sometimes, and added responsibilities for data science teams to do that. For example, we've implemented like a traffic light system around some of our deployments. So deployments which are deemed low risk, people can now push straight to production using CI/CD without needing review, which traditionally ops teams would have had to provide before code could be pushed into prod. We've had to do some work to align environments between like dev and prod, enable us to streamline those processes. We've set up an MLOps team now, and their central purpose is to really empower or enable data science teams by lowering the barrier to entry for some of the more complex jobs that are needed to productionize machine learning projects. So a lot of the things I've done have involved like defining and documenting common or standard design patterns that can be reused across all teams, addressing pain points such as setting up CI/CD pipelines for us, and also helping abstract away difficult tasks. For example, writing to our data platform, helping us create integration tests for our jobs, and also helping us build monitoring tools. So in terms of our second goal, accelerate. So as I mentioned, we knew we really had to work out a way to accelerate the data science process. And our thinking in terms of this goal has been heavily influenced by this book that you can see here on the right, Accelerate. So this was published a few years ago. It really talks about the importance and actually the business value of implementing a DevOps culture. And I think a lot of the principles in this book, are just as applicable to machine learning systems and MLOps. So the authors of Accelerate propose 4 KPIs that businesses can measure and use to benchmark their performance. And they've done a lot of analysis around these KPIs, showing that there's actually a causal link between improvements in these KPIs and underlying business performance. So I'm not going to go into too much detail about these right now, but just to summarize, so the 4 KPIs they recommend are measuring lead time, which is the time it takes from a request being made to a team and that request being fulfilled. So for example, a feature being made available, being exposed to real customers. They recommend tracking deployment frequency. So for example, number of releases per month. This may not necessarily feel immediately clear, like why that is a good measure of maturity in DevOps or MLOps, but the rationale for measuring deployment frequency is that it's a proxy for the batch size of work. Like if you can reduce the batch size of work that's being deployed to production, you tend to lower the risk around that work. It's much less variable. You're able to deliver, much more often. So ideally, you're able to drive value early and often through doing that. While reducing risk and just establishing those habits in a team for regularly, to getting work out there rather than working on like long-lived branches and deploying everything at the end of a process, which can be error-prone and delay feedback. The final 2 KPIs, mean time to restore and change failure rates. So these measure how often failures happen and how quickly you can respond to failures. And then the change failure rate as well is important. I think the authors really point out that in complex systems, failures are actually inevitable, but measuring progress in terms of like the number of releases that lead to failure is really important, but the time that it takes you to recover from failures is also critical, so that things can be corrected rapidly when they do go wrong. So lastly, our third goal is around quality. We've been heavily influenced here by this paper from a team at Google. So they actually propose a test score for measuring the maturity of ML systems. I'm sure many of the people here may have already read this before. It's somewhat of a classic in machine learning, but this team outlined a number of best practices and kind of tests for production systems, largely concerned about these 4 areas. So the data and the features and models, the models themselves, infrastructure, and monitoring systems. So the perfect system, according to this paper, could achieve a score out of 7 in all 4 of these areas. We pragmatically aim to achieve a score of at least 4 out of 7 in all our systems, which I think the authors state resembles a mature production system. And I'd encourage anyone to read through this paper and prioritize some of these practices for your given system. So some will be more important in some use cases than others, but yeah, some really important learnings from that. And I think this image on the right here, again, I think is really helpful illustration of all the different things that can go wrong in ML systems. So these are the types of things you really want to be getting a handle on, either through testing or monitoring, for example. And finally, before I hand over to Sam, the final thing we've done to kind of improve our processes and operations at M&S is gradually roll out new team structures. So over the last year or so, we've gradually been rolling out more and more of what we call mission-based teams. So, you know, these are relatively standard kind of agile cross-functional squads of people with different skill sets in them. You know, typically software and or data engineers, data scientists and or analysts, you know, product people, delivery people, sometimes, you know, marketing people, you know, quite different skill sets can be part of these teams. The idea of having that cross-functional team is that the team's enabled to build, run, and own a solution end to end. So they've got the right skill sets in the team to be able to do that. They've got the right permissions in the team. So that reduces dependencies between teams, speeding things up, enables that team to be empowered and autonomous to ship software themselves, establish those good practices to ship early and often, and benefit from that process of being able to make small deployments, lower risk deployments, and avoid delays. So ultimately, these teams have had great success so far. You know, they've delivered a lot of value, some great outcomes both for M&S and our customers much earlier. And on that note, I'm gonna hand over to Sam, who's going to bring this to light a little more, talking about some of our work in the growth and personalization domain.
Sorry guys, give me a second to set up. Just having some difficulty sharing screen.
I'm going to jump in and fill while you're sorting that one out, Sam. So thanks for that, Nick. Absolutely great session there, man. Really enjoyed it. We've had a couple of questions come in the Q&A, which is nice to see. So we'll get those at the end. By all means, please do keep doing that if you're out there at home and enjoying it. And just as I've said that, we've had another 3 questions come into the Q&A, so it was worth me coming on. Keeping you busy, Nick. How are you doing there, Sam?
I'm going to have to rejoin, I think.
Shoot, we can fill. I'm cool with this sort of stuff. It's obviously a good job we've done these testing beforehand. It's a very professional webinar we run, isn't it? We do all these tests in advance. So
should we use this time to answer a question or two?
Come on, let's do it. So I'll shoot to a question. What a great suggestion, man. Why didn't I think of that? Cheers, Nick. I'll come to that question. It's the second one down if you want to read along at the same time there, Nick. It's a question from Jitendra. Jitendra was asking about the process for turnaround time if there's a problem after deployment. So are you able to tell us any more about what happens if things go wrong during deployments? So
you know, originally when we set up as a team, you know, there's quite a painful process where, you know, if something went wrong in one of our jobs, we could push in a change, you know, often very, very quickly, but then that change would have to be handed off to a data engineering team who'd merge that change into a different code base. And then ultimately they'd have to hand off again to an ops team. You know, our mean time to recovery was if a change happened over the weekend, you know, it was sometimes taking 72 hours to rectify issues. Now we are empowered to fix those changes ourselves. So yeah, typically if we're bug fixing, we can just we can fix a bug, push that to our dev branch, run tests through our CI/CD pipeline, and if that passes, we can merge that into our main branch where it will then run in production. So it would drastically improve like our mean time to recovery.
Yeah, man. Sounds good. It blows your mind, doesn't it, when you think back to like sort of 72 hours? Like, come on, the world has changed. But I know by answering that one question, I'm sure there'll be a few more come in terms of around that. So in terms of that though, looks absolutely great. We have Sam back. Sam has shared his screen, which all looks good. So are you quite happy there, Sam?
Yeah, sorry about that. These things
No
always
worries.
happen on the website. So.
Yeah, no worries at all, man. Well, if you're happy, I guess me and Nick will disappear and we'll leave you to hand over at the end of your session, and we'll be back for the Q&A. So yeah, all the best, Sam, and I'll see you soon.
Cool, sounds good. Cool, hey guys. So I'm Sam. I'm a data scientist in the growth and personalization space. And today I'm going to be talking you through some examples of how we've actually built maturity into a number of projects in this area. Ooh. There we go. Cool. So before I get into the kind of nice, interesting, gory details of how we've actually built that maturity, I'm very briefly just going to talk a little bit about what we do as a team, who we are, and the kind of projects and problems that we solve on a kind of day-to-day basis. So first of all, growth and personalization is all about driving personalization that enriches customer experiences. So we're in the business of providing kind of mutually rewarding journeys. So we want ones that are kind of beneficial from a revenue and kind of business perspective, but also ones that are, you know, desirable from a customer journey and experience point of view. So there's various kind of online touch points that our predictions hit. So these are your more classical batch email marketing campaigns. Of course, we have a number of predictions on product display pages and carousels on our e-commerce website. And we're also in the paid ads and search space as well. In terms of who we are, as Nick was mentioning, we're very cross-functional. So we work in mission teams that are structured and organized by a product manager. We work with more analytically focused people too, and a number of kind of engineering-based roles as well. So there's a big pool and depth of knowledge to really tackle, available to us, so we can really, tackle quite interesting problems collaboratively in interesting ways as well. And in terms of what we work on, there's a few kind of hot projects at the moment. Campaign targeting models. So we have an array of propensity-based, probabilistic, and causal ML-based models that we use to ascertain risks of sending particular marketing communications to our customers. We have our more kind of classical recommendations models, so things that try and predict an next best category for a customer to purchase into. We have product recs on, product display pages. And another kind of work stream that is a bit more recent is really heating up at the moment is this kind of decisioning work stream. So, in session or pre-session on our various online touch points, what is the next best action that we can, put our customer on from a kind of personalization perspective. Cool. So that's a very high level introduction to the kind of data science work that we do in personalization. And I'm going to take a little bit of an abrupt turn and go into a very low level, the kind of common design decisions that have really helped us realize that maturity goal in quite a short space of time. So first of all, projects in our kind of remit are mostly structured as a mono repo. So all projects are kind of contained within a single code base. And that really allows us to kind of share and reuse a lot of the functionality that data scientists work on while, bringing their kind of projects to life. What I'll say what is most significant is this really nice design pattern we've used, the command pattern. So the command pattern is a behavioral design pattern that distributes responsibility through inheritance. Now, I find that definition and most definitions for design patterns online way too academic. And I think they're most easily understood if you actually break them down to a very code-driven, simple example. So the command pattern starts with a step. A step is an abstract-based class. You don't instantiate it directly, but everything extends from a step. So you might have an ML train step, which performs functions to train ML models. Within a step itself, you'll contain receiver logic. So a receiver will actually orchestrate and introduce the logic required to execute the step itself. So in this case, we have a training receiver. The training receiver will, do ML stuff, and the kind of extent that you require a receiver to execute that step-specific logic is really up to the engineer. We can completely decouple it, so we have an isolated training receiver, or we can actually containerize the methods to execute the step within the step itself. So it's really up to the data scientist and the engineer to kind of figure that out, is what makes most sense and what follows a common sense principle. And then finally, to tie this back to actually building a pipeline itself, we have this executor. So this is completely decoupled from the steps itself. It knows only how to invoke that execute method. And in kind of structuring our code in this way, we can get very nice, easily to write and adaptable data science pipelines that execute sequentially and very pipeline-like. So that's a very simple overview of the pattern we're using. In terms of how this looks in production, this is the system design of our project space. So we've got a pretty purist interpretation of the command pattern itself. We have a decoupled executor that knows only how to kind of execute that execute command of the steps themselves. We have various steps to do step-specific tasks. A lot of our ETL is very Spark driven. So we have a lot of kind of common utility methods that are inherited of all the kind of subsequent ETL steps. We make great use of parameterization in our SQL queries via Ginger. So there's a lot of kind of common utilities that are really reused there. And of course, we have our training steps and validation steps, which are more related to the kind of ML maturity tasks, which I'm going to go and speak on in the next few slides. But in terms of what one of these production pipelines looks like, if you look on the right there, we have a very simplistic pipeline, just two kind of nodes in that chain, I suppose, where we just essentially parameterize each of our steps, the executor, and then it's as simple as calling that kind of run pipeline. So yeah, very nice way to structure our code, and we found it's been very, very helpful. Cool, so that's the kind of overview of the design pattern we've used. It's very adaptable, and it's really helped us to kind of build a lot of the testing and monitoring components of ML maturity from the Google paper in a very modular way. In terms of those components themselves, so the data, model, infrastructure, and monitoring, how do these actually look in practice? So the first domain is concerned with testing inputs to ML systems. Now, ML systems learn from data, and unlike kind of traditional software, we can't specify data in the code, so we can't directly unit test it itself. So with the data domain, what we're attempting to do is to actually add sufficient testing so that we can monitor things like, skew. So essentially what we're looking to do with this data and monitoring is really look at the kind of covariate shift between what we expect the features to be when we train or when we offline forecast, and the actual features we get when we're scoring, so on the day. So we made use of this really nice open source library called Great Expectations, based off the Charles Dickens book. And the idea is that we encode the expectation, the distributional expectation of what we think those features should be. And essentially what we do when we score is we pass those inference time features through them and flag any violations where the computed means or standard deviations actually deviate from that expectation itself. So this has been really useful in a number of areas. So a lot of our ETLs rely on tables, for instance, that have a lot of load latency. So this can be up to 2 days in which we're waiting for transactions or logged email sends to be actually deposited into the tables themselves. So you can imagine if you have a low latency of 2 days and you have, a food spend variable that looks, backwards 7 days in time, you essentially could be missing up to 2 days of data there, which was going to have very undesirable kind of consequences on how your model predicts. So Great Expectations has been really useful in kind of flagging those issues and really helping us to kind of understand more about our data and what we can do to make our data pipelines more robust. Cool, so that's data. The second domain is model monitoring. So we use a handful of model monitoring tests to actually just detect any irregularity and to really just confirm that the assumptions of the model exercise that we're building is correct. So we use a lot of highly nonlinear, non-parametric models. And so what we do as a kind of first step is just to check whether that model we're training, actually how that performs alongside a very simple linear model. So the idea is every time we retrain, alongside this, we retrain a linear model with a lesser feature set that relies on less feature engineering. And we do that to kind of assess that real, cost to benefit trade-off between actually using very extensive feature engineering and very extensive modeling, and just to see if, if we're flagging any cases where, alongside our key ML metrics, whether that linear model is doing any better or not. Another thing we do is we retrain the model with a random noise feature. So this is really nice logging step. So this has been really helpful for kind of identifying a lot of buggy feature engineering in my experience. So we have a few categorical variables which have quite high cardinality, so a large number of unique values, and often these will be flagged by this kind of random noise step, where we essentially check the feature importances of that random feature against all the features inputted to our model. And where we see essentially that feature being lower importance than a random feature, that's kind of a suggestion that we actually need to revise that feature. And it's been really useful for kind of debugging a lot of the kind of feature engineering that we have in our pipelines. And then finally, probably my favorite one is this evaluation slicing. So essentially what we're trying to do with this is we're trying to identify slices of the data that we might think might behave qualitatively different. So for instance, if we're predicting on batch email campaigns, so at M&S we have two business groups. We have a food and clothing and home business group. It's quite conceivable that the way that customers interact with these different types of emails are going to be different. Food emails don't really contain call to actions, whereas clothing and home emails are quite a lot more personalized. So evaluation slicing is really good at kind of understanding if and where those kind of differences in the slices of your data exist. And if you are finding that there's a greater variance than a kind of threshold that you set, then maybe this is kind of instructive that actually you need to kind of revise your kind of global modeling approach and actually use more local models to handle that particular outlier slice of the data. Cool, so that's the model monitoring domain. The third domain we tried to solve for is the infrastructure, and this is a bit of a harder area to tackle in my experience. Now, why is this important? So ML systems, they are highly complex pipelines. It's not just kind of calling the predict method of a scikit-learn model. It's the real end-to-end testing and end-to-end integration. So the first thing we've done here is made great use of an AML and Azure machine learning based model registry solution for our versioning of our models. So essentially what we do is every time that we retrain, we upload that model to the registry. We supply a bit of metadata tags, so some evaluation metrics, but we also critically employ this kind of experiment version tag, which really should be called a project version tag. But essentially what it allows us to do is that if we make a big release and that model completely flops, we can just reset the project version to V1. So if V2 completely flopped, it goes back to V1. And then from then on, our scoring would use only the V1 models, and we wouldn't need to retrain, which is or could be quite a kind of time expensive operation. Another thing we do is we attempt to validate model quality before serving. So after we train each model, we make use of those metadata tags. And essentially what we do is we scan for models, for all models in our registry for that particular version. We take the best performing previous model on our kind of preferred ML metric, I suppose. And then what we'll do is we'll test that model and our recently trained model. And essentially what we'll do is we'll try and assess if that registry model performs better. So if that's between 2 and 5% better, we'll serve that registry model, else we'll kind of retain that trained model that we've just trained as part of that modeling pipeline. And then finally, we do a lot of end-to-end integration testing too. So essentially what we'll do is we'll construct a very toy dummy data frame of just only 5 rows. And for instance, we'll pass that end-to-end through our training pipeline. And this is actually really good for just flagging any potential silly bugs that enter the code base at 5 p.m. on a Friday. Essentially, it allows a full sweep through the pipelines, is really good at kind of spotting those embarrassing bugs in productions. Cool, so that is the infrastructure domain. The final domain is the monitoring domain. So now, again, this one is a little bit more difficult to kind of tackle. We have a dedicated monitoring domain just because we want to know that our ML system continues to perform as expected. We want to know not that it's just performant at release, but that it continues to be performant as we kind of realize that benefit that we speculated it might have during that proof of concept stage. So what we'll essentially do here is, one thing is we do a lot of systematic checking on whether that model or models we're employing regress in predictive quality. So one thing we do in particular for our kind of causal ML based uplift models will get a sense of whether there's any kind of statistical bias by using these really nice calibration plots, where essentially what we do is we group our customers, and then we evaluate whether there's model stability in that retraining. And then another thing we do is not really kind of a monitoring test that's mentioned in the paper per se, but we employ a lot of continuous code checking. So we have a number of kind of software engineering utilities that are ran as pre-commit Git hooks. So anytime we're committing code to the repository, we're employing a lot of code standardization tools that will, for instance, refactor the code to remove a lot of the kind of stylistic and I guess a lot of the kind of personal styles of the data scientist coding style from the project, which is quite a good thing, because I think anything that removes those kind of personal styles from a project is good, because it means that we focus more on actually during code review, focus more on the code functionality as opposed to querying over whether it's right to use single quotes or double quotes on our code. And then finally, we use a lot of coverage checking just to really identify where to introduce testing and understand where we can kind of improve from a testing point of view. Cool, so that's a rapid overview of how we've implemented ML maturity tests and monitoring tools at M&S. I'll just conclude this section by giving my personal reflections of using the ML maturity score. So first of all, there's large hurdles to address moving between proof of concept to production level ML systems. Second of all, vanity testing. Ticking off certain tests to achieve a higher maturity score is not always a productive use of time. So for instance, your data science pipeline might not actually have a large modeling component. It might be simply rule-based, but have a lot of feature engineering. I think it's very important to realize, where from a kind of common sense point of view, it's best to really focus your time in. And then finally, ML maturity is not equal to usefulness. So, ML maturity really helps us to get that reliable performant model, but actually identifying the value of, actually employing that model in the first place remains and always will remain as in the remit of the data scientist. And maturity is just something we use to really help us realize that value, if that value exists. Cool, so that's all on growth and personalization. Now I'm going to hand over to Duong, who's going to give our second use case on enterprise.
Thank you, Sam. So if you don't mind, I will quickly share my screen now. I assume everybody can see my screen. So thanks, Sam, for then talking through your use case in the growth and personalization team. So my name is Duong. I am a data scientist in enterprise data science team. I'll be talking about a specific use case within the enterprise data science team. So just a quick recap, the enterprise data science team looks after all the data science use cases that help the business run more efficiently. And this markdown optimization project is generally about trying to recommend optimal discounts that will help us to maximize revenue for all the products that will go into the markdown sale. This project, particularly the productionization part of this project, was a result of the cross-functional collaboration between many different teams. So there were three main core teams. Two come from the digital data department, which is the MLOps team, which was responsible for supporting the infrastructure setup and tooling for the data scientists, as well as supporting with setting up CI/CD pipelines. And the second team from the digital data that worked closely on this was the data science team, which is my team, which consisted of data scientists, data analysts, and a product manager. And we're responsible for building the back-end machine learning model. And that last but not least was the front-end development team, which came from the clothing and home department, and they helped build the front-end web user interface. Apart from these three core teams, then there were other people from other teams that supported on a part-time, like ad hoc basis. So including an architect who designed how all the components that all of us built should come together. The data engineering team, who helped us get the data into the platform that we use so that we can actually access the data. And last but not least was the infrastructure team, who looked after for some of the cloud infrastructure that the MLOps teams isn't accountable for. So we faced some business constraints when trying to build this, and it influenced how we designed the tool, and how we actually and then having to implement this. On the right-hand side, you see some images. Those are just screenshot of the web user interface of the Markdown tool. This tool is used by the central pricing team, and this team is responsible for implementing these prices and to make sure all the stores get all the prices and implement it and during the sale. This team still would like to have some level of control over pricing. For instance, they would like to be able to set the minimum discount or the maximum discount, or they would like to set things like sales through target, and decide which product should end up in Markdown, and when the sales start and end, etc. This is the reason why we needed a front-end user interface, and that's why the front-end development team from Clothing and Home team department came out and joined in to productionize this tool. And given that M&S is a large organization, so to ensure the smooth and collaboration, keeping things organized, and there are some certain rules that you have to follow. For instance, components from different functions must communicate via an API. And last but not least is that there are a lot of business processes that we had to follow just to get new infrastructure set up, which all boils down to us trying to design this tool in a way that help us get a functional product into production in an efficient way. And here is the architecture diagram, which mostly focuses on around the part that the back-end part that the data science team is accountable for. So you could see that this little green box at the very bottom, that's where the front-end user interface is going into. So the back-end and front-end were communicating with each other via Kafka queue. And the main two components of the back-end machine learning model section, which the data science team is responsible for, is firstly is a daily batch process ETL and model coefficient derivations. So these were essentially the Databricks notebooks that were scheduled by an Azure Data Factory pipeline. These were running all the extract, transform, and load operations and running all the model training, which resulted in model coefficients such as elasticity coefficients and trends and baseline, etc. And all of this data and some other relevant data were saved into a SQL server. And this SQL server is accessible by an AKS cluster, and that's the AKS cluster is where the scoring takes place, and this is like a near real-time component which communicates directly via the Kafka with the front-end user interface. So each time a user uses the front-end web interface to request prices, and that's request gets processed in this AKS cluster, and all the price predictions get computed, and the optimum prices were fed back to the user interface. So this is just to go into a bit more specific from MLOps point of view about how we worked to go about to actually get these things through the process. And this one focuses on the work that the data science team and MLOps team from digital and data collaborate with each other on the back end side. So the MLOps team is accountable for bringing a tool into production. So it's and helping us setting up the CI/CD pipeline. The general workflow of the data science team, then it's obviously it starts from designing, developing, and building it. Everybody works on a Git feature branch, and once only once a component has been finished developing, then someone can raise a pull request to merge it with development. And thanks to the CI/CD pipeline that's already been set up, things like unit testing or checking the formatting, whether it is compliant to any kind of set rules that we have any set of standards that we preset ourselves, and this runs automatically. Within the development branch, then that's where integration testing occurs, which is done in collaboration with the front-end development team to ensure that from end to end, from the point of a user triggering the tool from the web interface up until everything is being processed in the back end and fed back to the user interface, whether everything is smoothly there. And once everything, all the tests are clear, then we raise a pull request to merge it into the main branch, which is where the production environment is. Given that the MLOps team is accountable for everything that is running in production, including making sure, say, like our source table are updated with the latest data, because these source tables are like our core factory tables that we are actually not, as a data scientist, we are not accountable for, but we are user of these data. So just to make sure that these things are actually integrated with each other well in the production, and that's why MLOps team have a say in with regards to reviewing the pull request, every pull request that goes into production. However, some of the changes that we implement aren't actually going to affect, and some not all of them necessarily affect things that the MLOps team is accountable for. So which is why we introduce a traffic light system, depending on which, so if, say, it's a change that's not going to require MLOps teams having to like specifically review, then we mark it as green, and that way then it can get pushed to production faster without much delay. But if it's, say, something that touches on a section that may require MLOps further careful review, and that's where, say, we can set it to a different light, so set it to red. A bit more details into like because there was a clear difference between the way that we developed the batch processing, which ran in Databricks, and the near real-time component, which ran in AKS cluster. Given that the batch processing was run on Databricks, which is looked after and set up by the MLOps team, so we got to actually develop things in Databricks and testing everything there. It all was smoothly, and we also had the choice to do things locally, say like code in PyCharm, or just use the IDE with use the Databricks environment itself as an IDE. So to make sure that we to make it easier for us, then the CI/CD pipeline that was set up, and it automatically sync to make sure that everything in the Git repository can be synced automatically back into Databricks and automatically back into our local environment as long as we pull it. And that made the development workflow a lot faster. With regards to the near real-time component, so the core development unfortunately wasn't actually done within AKS, because AKS was set up by a separate team called the infrastructure team. To help speed up and just to avoid additional bureaucracies, and core development initially was done outside AKS. It's only when it comes to pushing things into development branch, when integration testing is done, then we had the AKS test cluster to test things in before we are pushing finally to production. With regards to the tool sets that we are using, then for the things that were running on cloud, then it was all done in PySpark, given that our data is all hosted in the cloud as well. So, and PySpark is, as a distributed computing, is a lot more efficient. With the AKS cluster, then everything was coded in pure Python. We use all Microsoft offerings, so Azure DevOps, Azure Data Factory in order to schedule Databricks notebooks, Microsoft SQL Server, where the data was hosted. Some of the data was hosted that allows which AKS cluster can access to extract data and run the scoring. And the Kubernetes cluster is also an Azure Kubernetes cluster. So that's a little bit about the kind of tool sets that we've been using. I did notice some of the people have been asking, but what kind of tools we have been using. So I hope that also answers your question. So that's last but not least is a little few key points, like key learnings that I personally have gathered after working on productionizing this tool was the best architecture design for a specific project largely depends on what existing tool sets that we or any existing infrastructure that we have in place. If we want to be able to deliver them more efficiently and trying to maximize the value against the effort that we put in. And it's better to just try to automate as much as possible, be it like testing or reviewing pull requests or trying to synchronize codes across to help us develop faster and test faster. And lastly, the test coverage or how much logging to put into place, to what extent we write unit tests, etc. It's very much depending on the specific use case. So we mostly use our own judgment to weigh the pros and cons between trying to push to the production faster and to ensure that it's actually of good quality. So next, then I'll hand over to Nick to help wrapping up. I'll stop sharing now.
Thanks, Duong and Sam. So I realize we are already over time, so I'm going to talk super fast now just to get this wrapped up. Hopefully these slides are coming back up. Okay, here we go. So just to wrap this up, just to summarize our journey so far, you know, we have grown significantly as a team over the last 18 to 24 months, now around 30 people. We're now spread across at least 12 different product teams, whereas, you know, 2 years back, we were just operating as a single data science team. And we've gone from having 0 models in production to now at least 16 systems working, you know, operating at scale. In terms of the impact we've made, here we go. Whoops, here we go. You know, one of the most impactful things we've done, especially around our progress around the Accelerate KPIs, is reducing manual steps in our deployment process. We've gone from 8 to 1 or 0 now, depending on the risk of a deployment. It's enabled us to reduce the time to recover from failures, like drastically, like, you know, from 72 hours at times, as I described earlier, to you know, potentially a few minutes now. Uptime of our services is dramatically improved as well, and we've gradually been developing that culture in our teams to release to production early and often, and developing that skill set to be able to do that safely across all the individuals in the team. And you know, we've had a lot of impact across our teams in the last 18 months, driven at least 70 million of annualized incremental revenue for the business, and you know, there's a big feeling that we're really only just beginning still. Thanks. That's the crux of our talk. I think perhaps most importantly of all, over the last couple of years, we've really built an awesome, friendly and welcoming team. But this is a picture from our last team day in the autumn. We are continuously hiring. If any of the topics we've covered today has piqued your interest, like, we'd welcome an application. We'd love to hear from you. We've got a QR code here which you can scan. I believe we'll be sharing the slides back, so after the talk, so feel free to scan in your own time if you'd be interested in applying for one of our roles. But yeah, thanks a lot for joining today. It's been fun, and yeah, I don't know if we have time for a question or two, but I realize we are over.
We'll make a quick judgment on that one, but I guess just quickly, as is being shown in the chat, it's always nice to get a bit of a virtual round of applause, actually. So rather than jumping into the questions, I will use a minute just to kind of say a few thank yous. I am a bit conscious of the time. People obviously do nip off to different Zoom meetings, etc. But just quickly, Serkan, in fact, actually, if I could ask all of you to turn your cameras back on, Sam and Duong as well, please. It'd be great to have you back to say thank you in person. But just in terms of that, fine for a few quick comments. Serkan, great work. That was very insightful. Thank you for sharing your experience with us. Noor, massive thanks to Nick, Sam and Duong for an excellent presentation. It's very generous of you and M&S to share so much detail on your MLOps journey. Imran, great overview, use case, thanks to all. LM Marshall, thanks Nick, Sam, Duong, really interesting overview. Where are we? Awesome stories on the journey, well done. Many thanks for a great presentation. Thanks Duong and Nick. Nick is in capital letters there, Nick. I don't know what you've done to deserve capitals, but I've got to call it out. Well done, sir, well done, sir. And an anonymous person says, thanks, great session. Chelsea, clapping emoji, thank you, great session. Thank you all for sharing. The list goes on and on there, guys. So really, really well received session. In terms of the Q&A, it's a bit of a difficult one because there's some great questions in there. And we've actually got 18 questions as well. So I'm a little conscious of time, and I'm a bit worried that if we just jump in and take a couple of random ones, whether it gets a bit lost in context and whether it's perhaps best to kind of go through them, perhaps turn it into a blog post. I don't know whether you three would have the time to kind of look through the questions and put something together, or whether we just attempt to do something in about 3 minutes flat and perhaps miss a few things. What do you think, Nick? Is it worth trying to turn it into a bit of content to share with the community?
Yeah, I think that's going to be best. Yeah, we'll take a look through this and we'll pick out
100%, man. Just quickly to call it out then. So again, Jitendra, Imran, Ayuli, Antonio, Robert Wolf, Noor, Jitendra again, a couple of great ones. Ryan, Sam Watts, great questions from everyone there. Jamie, we can see all your questions there. So we'll grab a copy of those after the webinar, and between us we'll put it together. And obviously we've got everyone's contact details from the webinar, so we'll put it into a little blog. That'll maybe give Marks and Spencer some more content to put on your hiring website and stuff like that as well, and attract some more talent. So I guess just kind of wrapping things up then. Marks and Spencer has been a partner of ours for this year. They presented at our live conference at the end of last year, gave a session during the online data science festival, and obviously come back now to deliver a sandbox session. I'd definitely like to say a big thank you to Marks and Spencer's. We really appreciate the support. Obviously it's free events, free community, all about sharing knowledge, and you guys have really helped us support the community that we run, and have come with some absolutely great content, which has been very clear today. So thank you very much, Nick, Sam and Duong. How did you find it today? Is there any last words from any of you just as we bring things to a close? I'm going to pick on one of you. I'll start with you, Nick. You're the boss. Go on, Duong, come. How was it?
So, well, thank you everyone for joining. I've seen like there were so many people joining, and I'm happy that there were so many people that are interested in hearing us.
Yeah, totally.
And,
it's really nice to
I have
see
a chance to actually share. And I wish we could actually have time to actually go through all the questions. I've seen like there are 18 at the moment.
Very good questions as well, wasn't there? So you never know, maybe we get the chance to get Marks and Spencer's back as well, and we'll make sure we have time for the questions next time. But I'm really glad you've enjoyed it. How did you find it, Sam?
Yeah,
everything
great.
You dreamed of, basically.
Everything I dreamed of, yeah. A few technical difficulties, but I think we got over them. But yeah, just to reiterate what Duong said, yeah, really great questions. We'll do our best to answer those in some content, yeah.
Perfect. Thanks very much, man. I'll come to you last, Nick, and then we'll just draw things to a close.
Yeah, thanks for the engagement, everyone. Yeah, really fun. Happy to be here. Session. And I think it's probably my fault that we've overrun actually so much. So apologies.
We have a zero blame culture at the Data Science Festival, mate. Yeah, there's no blame at the Data Science Festival ever. So just drawing it to a close, just to reiterate what everyone said, really fun session. Really appreciate you all joining us from wherever you are in the world, coming to be part of the community, coming along to learn with the team here at Marks and Spencer. So thank you all very much. Hopefully you get the chance to come along next week or to some future sessions. But once again, thanks again to everyone from Marks and Spencer's, and hopefully we'll see you all very soon. So thanks and goodbye, everyone.
Thank you.